Hi guys, this is day 3. If you want to build a RAG app using a standard tutorial, it will fail in production. Today we are looking at two-step stage retrieval pipeline and why just throwing a vector database at the problem isn't enough. See, if you have a 500 page document and if you upload it in your LLM, so what will happen is your context window will get filled very fast. So these are some challenges you face while building standard RAG apps. Firstly, what beginner try to do is they just took a document and just chop it every 500 characters. So what happen is the context behind the whole sentence is lost. For example, if there is a sentence called I am going to Paris, so if it doesn't care where the 500th mark will end, it can end like this. The word PA Paris will be chopped into two parts. PA will be separate and RIS will be separate. So what happens is the semantic meaning of the word is lost. So what is the solution to this? There are two solutions for this. We use recursive chunking with token overlap. So now you may have a question, what is recursive chunking? So like we have two sentences. So what will happen is your sentence one will be covered two times. Like I am going to Paris and it is a hot day there. And it is a hot day there, so I enjoy my trip. So the sentence is covered in the first as well as in the second one. So the context is never lost. And the second thing it does is it literally finds where the paragraph will end, where the commas are there, and where full stop is there. So these are the two techniques that are used, so our semantic meaning is never lost. So the semantic chunking ensures that embeddings represent the complete units of meaning rather than arbitrary sentences or strings that may end in middle or the context is destroyed. So now you may have a question. We cannot put our whole 500 page document in our LLM because it will fill the context window very fast and your API cost will skyrocket. So now what should we do to fix it? The answer is Bi-Encoders. But is Bi-Encoder really the answer? First, let's understand what Bi-Encoder is. First, we'll talk about what are encoders. Encoders are nothing but translators. It translates your words into math that the computer or the LLM can actually understand. We will understand Bi-Encoder with the help of example. Suppose you are in a room and I hand you a piece of paper in which a question is written, and there is another person in another room and I hand him a document in which the answers to that question are. So what Bi-Encoder does is it don't process both the question and answer in same time. What happens is the document that is given to the person to convert into embeddings, it is given much before when the question is asked. So what happens is it will take some time, like it may take hours or days, but that process will be already done by the time you give it some question. So your whole database will be a giant plot of vectors. So when you give it a question, so what happens is the Bi-Encoder really quickly converts your question into a vector embedding and tries to match it with the whole big graph that was created weeks before or at the time of training. So it finds the and retrieves the top 100 most suitable matches that matches the semantic meaning of the question you just passed. But the problem with this Bi-Encoder is your question was passed separately and the database is passed separately, so they don't actually interact with each other. It is just vector mapping afterwards. So you can consider Bi-Encoders, they are really quick but they are little bit dumb. So our Bi-Encoder was dumb. So what we can do is there is a possibility we can pass question and the database at the same time. So what it is like stapling a document. We passed both those things at the same time. So but there is a problem with this. In Bi-Encoder, the document was like processed long before the question was asked. But in the case of cross-encoder, both the question and the document will be calculated or will be processed at the same time. So what happens is it will be a huge computational task and it requires almost O of n square time complexity. So if so for example, if you have millions of documents and a single question, so what will happen is your single question will be mapped to that 1 million document and everything will be processed simultaneously, so your server or your system may crash and catch fire. So what is the answer to this? what we does is we use both bi-encoders and cross-encoders simultaneously. Firstly, we will process the whole thing by a bi-encoder. So it will only give the 100 most relevant documents to us. After we have those 100 most relevant documents, then we pass it on to the cross-encoder. So then cross-encoder picks our question and then maps it with the 100 responses we get and calculates them and find the top 3 best answers. Couples the query and document together. It uses real-time self-attention mechanism like transformer do, forcing words in the query to mathematically map to every word in the document. So at the end, the top 3 chunks are then sent to the LLM, and the LLM then gives us the best answer, and the chances for hallucinations are almost reduced, or we can say it almost zero. Now we will see more about this on day 4.